Okay, so now we're moving on to parabola graphs. So there's two types of equations this graph has. I'm going to be working with the first equation, then we're going to learn how to determine the equation for it, then how to draw the graph. Then I'll show you all the next equation. So firstly, what does a parabola graph look like? It either looks like a smiley face or I could have drawn one as a sad face. So as you see, the graph is drawn like this. Look at this bottom part here. It's kind of where your graph starts to turn. So we call this point in the middle, that coordinate, a turning point. So that turning point will have its own x value and y value. Okay, so this is the equation that we work with. Well, the first one, y is equal to a, open brackets, x minus p squared plus q. So remember in your straight line equation, we had to find certain letters that had to be changed into numbers. It was your M and your C. In this graph here, it's going to be your A, your P, and your Q that we need to fill in as numbers when they ask us to determine the equation. So something that you should just know, this P value is actually the X coordinate of your turning point, and this Q value is your Y coordinate of the turning point. So whatever numbers you have here, you can just take them out and put them in your turning point coordinates. So if this Q is 2, for example, you'll put your Y value as 2. And this P now, be very careful with the sign. This is a rule. Let's say this was minus 2. When I'm putting it as my X value, I need to change the sign. So I'll put it as a positive 2. So you write your Q value as your Y for the turning point, and your P value, just flip the sign and put that as your X. Then once we filled in our P and our Q, the only thing left to solve for is our A. So what we'll do is, see there's an X and there's a Y. We'll take a random coordinate from the graph, put it in your X and Y, then the only unknown will be your A. So you can shift solve and you should get your A. So let's take a look at this example now. They say determine the equation, and this is the graph information that they give us. This point here, I already can see it's my turning point, right? And this is just a random coordinate. So they said determine the equation. First things first, I need to write out my general equation. So I'll write out y is equal to a, open brackets, x minus p squared plus q. Okay, now let's start filling in your a, p, and q. Already p and q I know is turning point, so I look at my turning point coordinates. See, your x value should be your q and your y value should be your, your x value should be your p and your y value should be your q. But remember, with the p, you have to flip the sign. So see, this is minus 1, so I'll put it as plus 1 in my p's place. Then my q is minus 2, so I'll put it as minus 2. The only one you're changing the sign of is your p value. Okay, so I have p filled in, have q filled in. I just need a. So what am I going to do to solve for a? I'm going to sub in a random coordinate at x and y, and there's a random coordinate here. It gave me 1 and 2. So I'll put 2 is equal to a, open brackets, 1 plus 1, close brackets, squared, minus 2. Now you can see the only unknown here is a. So I can shift solve and I got my a. Now I can fill in my whole formula. When you're filling in your whole formula at the end, the only thing that should be in letters is your y and your x value. Your a, p, and q should all be filled as numbers. The reason why I put a as blank is because it means it's 1. Right? When you want to show it's 1, you don't have to put it down there. And then that's your final equation. Okay, so we did how to determine the equation of a parabola using that PQ equation. Now we're going to learn how to draw a graph from that PQ equation. So here's if they were to give you the equation, you need to know how to draw the graph. So there's 3 things you need to find when you need to draw a parabola graph: x-intercept, y-intercept, and turning point. Now, remember, your turning point is already given in this equation. You just need to fill it in. Opposite sign of this, and then just copy this down. So your turning point will be minus 1, because you flip the sign for your x value, and then minus 2 for your y value. All right, so our turning point we have. Next, we need our x-intercepts. So in order to get x-intercept, we make y 0. In order to get y-intercept, we make x 0. One thing you should know about a parabola graph is it has 2 x-intercepts, so you should get 2 x values. So this is, in order for us to get 2 x values at the end here, we're going to have to use mode 5-3 method. So this is what you do. So I wrote out the equation. Now remember, it's x-intercept, so we need to make y 0. So I made y 0. Now how am I going to solve this? I can't shift solve because if I shift solve, I'm only going to get one x value. And I know I need 2. So what I'll do is I'll just open all this up. So this bracket is squared, so I'll twin bracket it, then FOIL this, and then I'll just bring the minus 2, and now I got this. I simplified it, and now I got my trinomial here, or your quadratic, you could say. Now you can mode 5.3 this answer, and you should be able to get your two x values. So I put this in mode 5.3, and I got minus 2.4 and 0.4. So these are your x-intercepts now. Now remember they're coordinates as I told you. So you write down your coordinate. There's your x-intercept value and there's your y value, 0. There's your other x-intercept and there's your y value, 0. So we have our two x-intercept coordinates. Next, we need to work out the y-intercept. So for y-intercept, we need to make x 0. Here's my equation. In x's place, I need to put a 0. So I did that, and when I put in the calculator, I got minus 1. And now remember, write it in coordinate form. Here's your minus 1 as your y, and then obviously 0 is going to go in x. So then we have all three things now. I can plot my graph. So you'll have, in the paper, they should give you graph paper, but you draw your Cartesian plane, you plot all your coordinates. Plot your y-intercept as 0 and minus 1. Plot your x-intercept with the minus 2.4 and the 0.4. And then you plot your turning point, which was minus 1 and minus 2. And then you connect your dots and extend the graph. Okay, so this is the next equation we work with in parabola graphs. It's our quadratic equation. So you all remember the first one that we did was this equation here, our PQ equation. Right, that was our first equation. That's the PQ equation, right? Or you can call it like the TP equation, because we get our turning point from this equation. This is the second equation we use with parabolas. It's our quadratic equation. Okay, or you could think of it as your trinomial equation, so you remember it. Now, I'm going to teach you all how to draw a graph if they gave you this equation, and then I'm going to teach you how to determine the equation. So, same thing when it comes to drawing a graph. You need the same x-intercept, y-intercept, and your turning point. But now it's a little bit difficult to get turning point from here because in this equation they give it, like the turning point's already there. So we're going to have to find out different ways to work this turning point out. So here's the example. They gave us y is equal to x squared minus 3x minus 4, and they said, right, draw the graph. So immediately from looking at the equation, I knew it was a parabola because it's a parabola equation, right? It's the second equation of a parabola graph. So let's find our three things. X-intercept, it's easy to find. We're going to substitute y as 0. Now remember parabolas, I told you, you'll have two x-intercepts. So I'm going to have to do mode 5.3 here. But this is already in quadratic form, as you can see. So I don't have to open up anything. So for x-intercept, write your equation. Now for x-intercept, I need to substitute y as 0. And now this is a trinomial, so I can mode 5.3, and I get x is equal to minus 1 and x is equal to 4. So remember, these are your intercepts now, so you have to put them as coordinates. So I put on my first pair, minus 1 goes here and 0 goes here. 4 goes there and 0 goes there. Remember, zeros are your y values for x-intercept. Then I need to work out my y-intercept. For y-intercept, I need to substitute wherever there's x as 0. So see, in place of x, I put 0. And I put in the calculator, and I got an answer of minus 4. So I write it in coordinate form. My y-intercept coordinate will be 0 and minus 4. Okay, so we found our x-intercept coordinates. We found our y-intercept coordinate. Now all that's left is for our turning point. Now remember, with this equation here, it's hard to get turning points. So this is what you have to do. With this equation, you can just get the turning point from here and here. But now when it comes to our quadratic equation, this is what we're going to have to do. This is a set formula for turning points. But what does it give me? When I put this in and I plug in all my coordinates and whatnot, I get the x value of my turning point. So you'll have your turning point, which will have its own x value and y value. This equation here, I use to get the x value. Once I get the x value, I need to get the y. I'll show you all now how to get the y, but let's work with this. So to get turning point, I write out my equation. X is equal to minus b over 2a. Right, so x is equal to minus b over 2a. Where am I getting this b and a from? See in your quadratic equation, A, B, C. So B will be minus 3, C will be minus 4, and my A will be 1 because that's in front of the X. So when I'm substituting B, B was minus 3. So I put minus, open brackets, minus 3. All over 2 times A was 1. So 2 times A. Put this in the calculator, I got 3 over 2. So again, this is my X value for the turning point. So I got that. Now how am I going to get the Y value for my turning point? All I do is I take this X value and I go and substitute it into my original equation as X. So wherever there's an X, I'll go now substitute 3 over 2. All right, so that's what I did. I wrote out my equation. Wherever there was X, I substituted 3 over 2. Got an answer. My answer was minus 6.25. Now this is my Y value for the turning point. So you can rewrite your turning point as 3 over 2. You can even put this in decimal form if you want to. It would have been 1.5. And then your Y value is minus 6.25. So you have your turning point. So we have all things now. We have our x-intercept, y-intercept coordinates, and our turning point coordinates. So then after that, you can go and take your Cartesian plane, plot all these dots, and then draw your graph. Okay. Also, one more thing when it comes to parabolas, remember the A in your equation. So the A from there and the A from here. Your A's basically tell you whether your graph is a smiley face or a sad face. If the A's are negative, then your graph should look like a sad face. And if the A's are positive, then your graph should look like a smiley face. Okay, so now it's going to be remember we were dealing with the quadratic equation of parabola, the second one. So it's going to be how we determine the equation. We did how to draw the graph, let's do how to determine the equation. So what you all should notice is, when they give us a graph, and on the graph they give us our two x-intercepts, that's the graph where we mainly use the quadratic equation. You can still use your PQ equation, it all depends on what equation you feel comfortable with using. But also it depends on the question they ask you, because if they give you this graph and they want this specific parabola equation, you're going to have to work this one out. You can't use the PQ one. Okay, so let's take a look at how we're going to do this. First step, you need to write out the general equation. Y is equal to ax squared plus bx plus c. Okay, so then next step, you need to write out this equation. This is a standard equation I want y'all to learn. Okay, so this y is a random y value. The a is obviously your a, tells us if the graph is happy or sad. This x and this x are both the same. It's another random x value. This x1 is actually your first x-intercept, and this x2 is your second x-intercept. Okay, so one thing you should note that when I'm substituting these intercepts into their places, I need to change the signs. So let's go with that. Y is equal to ax. If I'm substituting my x1, it's now going to be plus 3. And then when I'm substituting the second x-intercept, it's going to be minus 2. So see how I change the signs. Right, next I need to substitute numbers in x's and then the y. Now remember I told you these x values are the same. So what am I putting in that place though? A random coordinate. The random coordinate I was given was 3 and 4. So what I'll do is, in place of the x's, I'll put 3. In place of my y, I'll put 4. And that's what I did here. So the whole point of this equation here was for me to solve for the a. Right, so let's see how I'm going to do that. I'll shift solve because a is the only unknown. And there I got a is equal to minus 1. Okay, now I need to rewrite the equation. I'm going to rewrite this equation. I'm going to fill in a's value. I'm going to fill in x1 and fill in x2. These x's and your y, I'll leave it as that. So see, I got y is equal to minus 1, which was my a, into x plus 3 was my first x-intercept, and then x minus 2 was my second x-intercept. Now from here, how am I going to get to this equation that they want me to get to, my quadratic? All you're going to have to do is, see there's two brackets next to each other. You're going to FOIL these two brackets together, and then you're going to make one whole new bracket. And then see there's a number on the outside, your a, you're going to take that and distribute it inside. So let's see how we're going to work it out. So open up the formula is the next step. Here's my two brackets. I'm going to FOIL them. So x times x will give me x squared. And then after you open it up, this is what I end up with. X squared plus 1x minus 6. Now remember to put that in brackets because your a on the outside, you need to now take the a and distribute it to each of the terms on the inside, like so. So then after you distribute, so you're taking your minus 1 times all of these terms, this is now the formula that I get. And this is in fact your quadratic formula. This is the formula that they wanted. Okay, so now we're going to be doing all the other aspects of parabola graphs, okay? So when they talk to us about domain and range, for domain, you need to think x values they're talking about. Then for range, you need to think y values they're talking about. So what specific x and y values are they talking about? So when I say domain, I'm talking about how the graph can stretch this way along the x-axis. And when I talk range, I'm talking about how the graph can stretch along this way, a y-axis. So notice here and here is where the graph is gonna stretch along the x-axis. And what you'll notice is for parabolas, this graph is growing and growing because see it's going here and here. That means it's going to infinity. So it's growing all the edges. So it's gonna go all the way to that side and it's gonna go all the way to this side. So we have a set domain for all our parabolas. As it's stretching continuously onto that end, that's the negative end. So it says it goes to negative infinity. And here it's stretching all the way to this end. That means going to positive infinity. So we say for your domain for parabola, which is standard, this will always be the domain for parabolas, will be x is the element of negative infinity all the way to positive infinity. That's where the graph stretches from. Also, another thing you must add to this side is you must always put x is an element of real. And then you can put what's in brackets here. Okay. Then your range now, we said we're looking at it's stretching this way along the y-axis. Now notice these two parts here are stretching all the way upwards, which is fine. That means it's going all the way to positive infinity. And if it is stretching all the way down, it'll be to negative infinity. But now see, I have a restriction here. It's not stretching beyond this point. So when it's stretching here, I'll look at, because it's range, I'm looking at the y value. So that's my restriction. The restriction is actually -2. So the graph for your range technically stretches from -2 all the way to positive infinity going upwards. Do we see that? And that's why I have, the reason why I put square brackets, because remember the difference between square brackets and circle brackets. Circle brackets means it's not going to include this number. Now, why do we use circle brackets whenever we're using infinity signs? Because we don't know what number infinity is. That's why I'm going to use circle brackets, because I can't include it, because if I don't know the number. The reason why I'm using square brackets here is because it is including the 2, because the -2, because -2 is a coordinate on our graph. Okay, so let's go over it again. Domain for parabolas will always be this. They're going from negative infinity all the way to positive infinity horizontally. Right, and don't forget to put your x element of real. For your range, it's the graph stretching upwards and downwards. Upwards, it's going to positive infinity because I can see it's still extending. Downwards, it's got a restriction. It's your y value of your turning point, which is -2. And because that is technically a coordinate, I'll put square brackets. And here you must also put y is the element of real. Okay. Then the next thing we're going to be looking at in the parabola is axis of symmetry. Now, symmetry, you'll know what that means. It means if I divide a shape or whatever the case may be, it must give me equal halves. So if I were to cut this graph this way, I'm not going to get 2 equal halves. But if I were to cut it straight down in the middle, like this, then you see that I divide it into 2 equal halves. So they'll normally ask you this in a question. They'll say, what is the equation for your axis of symmetry? All you do is you write x is equal to, and the value that you have to put here is the x value of your turning point, because that's where the graph cuts directly in half. So my x value for the turning point is 1, so x is equal to 1 will be my equation. Again, that's if they asked you, what is the equation of axis of symmetry? Same for here, for example, if they gave me 2 and 4. They said, what is the equation of axis of symmetry? First, draw your line so you know it's cutting the graph in equal halves. What's your equation? It's literally just x is equal to your x value of the turning point. And that's your equation. Okay, now remember those 2 equations for parabolas, right? There was this one here, which is our quadratic, and then there was this one, which was our PQ equation. So now what we're going to learn to do is we're going to learn how, if we given one formula, how can we get the next formula? So let's learn first how to get from our quadratic formula to the PQ formula. So this one, there's a certain method we have to use. It's called the square method. I need y'all to learn this. So let's take a look at the example. They gave us the quadratic formula. Now I need to get to the PQ form. So all you have to do is write down your first two terms. So see, I wrote down my first two terms, x squared minus 4x. Then what you need to do is you need to add and then subtract a certain component. This component, how do you get it? You take your second term number, which is minus 4, you divide it by 2, and you square it. That's the component. Your second term divided by 2, all in brackets, squared. So let's do that. I wrote down my first two terms as said. Now I need to add and subtract the component. So what is the component? Second term is minus 4 divided by 2, all in brackets, squared. So I have to add the component first, then subtract the component, and then see your constant, put that right at the end. So this is how we got this step now. Now how are we going to work out from here to get to the next? So to get this first part here, okay, first thing you do is see from when you minus the component. Bracket that part off and bracket this part off. Now, I want you to put this in the calculator and you're going to get your last term here. So when I put this whole thing in the calculator with your minus sign, I got minus 2. So now I know that I can't touch. Now I need to look at everything here in the front. So what am I going to do? Write your f of x is equal to, make one bracket. Now look at your first and last term here. Remember I told you when you bracket this, you forget about it. Look at this 1, 2, 3 terms here. Look at your first and your last term. This one is x squared. This one is minus 4 over 2 squared. Forget the square signs. Just look at the raw number. This is just x. This is just minus 4 over 2, which gives me minus 2 technically. So this is minus 2 and this is x. So what you do is, remember the bracket you created? You take your first term, which was x, forget the square sign, and you take your last term, which was minus 4 over 2, which became minus 2. Forget the square sign. And then what you do is you add the square sign on the brackets, because technically we know they're squared, but we're forgetting it in that motion, and we're bringing them down, and then we're putting the square on the outside. Okay, now if you're wondering why didn't we touch this or where did this go? It's simple. See, this whole bracket is squared now. If I were to FOIL this, where I open twin brackets and work it out, I'll get this exact row of numbers. So you don't need to worry about that. Just follow the steps. Make a bracket, put a square on the outside. Take your first term, put it down. Take your last term, put it down. Right, the reason why this is minus 2 is because minus 4 over 2 gave me minus 2. Right, and then put this whole part in the calculator and I got minus 2. Now notice you made, from your quadratic formula, you made it to your PQ formula. Here's your P, here's your Q, and then your A is 1. Okay, next we need to know how to get from our PQ formula to the quadratic formula. So this is easy. There's the following example. They gave us the PQ formula. All you need to do here is, you don't have to worry about any square method or anything. You just have to start simplifying and opening up. So notice that this is squared, so I can make twin brackets. So that's what I did. I opened up twin brackets. Now I need to FOIL this bracket. After I FOIL this bracket, it opens up into this. Now, why do I still have it in brackets? Because, see this number on the outside? I have to keep bringing that down. And now that I have this one final bracket, I'm going to take this number and I'm going to distribute it inside. So I'll take this 2 and I'll times it inside here. And then now I got this. Keep bringing your 3 down. The 3 is not going to get multiplied anyway. So let's go one more time. To get from your PQ equation to your quadratic equation, you need to start simplifying. So foiling, distributing everything until you come to your quadratic at the end. So here we can see it's squared, so make your twin brackets. Then FOIL these two and put them in one bracket. Then distribute the number outside into the bracket. And now I have all this opened up. Then you simplify and then you get your quadratic formula at the end. Okay, next graph is the hyperbola. Now the hyperbola graph basically looks like two boomerangs, okay? So we know this is quadrant 1, 2, 3, and then 4, right? So it's always either in quadrant 1 and 3 or in 2 and 4. How are we going to know that? Firstly, let's look at what the hyperbola equation looks like. So this is your standard hyperbola equation. Y is equal to A all over x minus p plus q. Now remember, I need you all to go and learn all these general formulas for each one of the graphs. Now, how do we know where to put our graph, like in 1 and 3 or in 2 and 4? So see this A value on top of your graph. You need to see if it's positive it's going to go in quadrants 1 and 3. If it's negative, it's going to go in quadrants 2 and 4. Okay, that's just something you should learn. And then what does this P stand for and this Q stand for? It's not parabola anymore. In the parabola graph, we know that this is our x value for the turning point and this is our y value. But this graph doesn't have any turning points. So this P and this Q is now going to be our asymptotes. Now what are asymptotes? Asymptotes are basically dotted lines. There's going to be one horizontal asymptote and there's going to be a vertical asymptote. So can you see this is my Cartesian plane, right? But when I draw asymptotes, I'm going to draw it on top of this Cartesian plane. I'll show you an example now. But when I draw this asymptotes, when I'm drawing my graph, I need to use this asymptote as a guideline. So like I can draw my graph where it mustn't touch the asymptote line, but it must curve with the asymptote. See it like that? You're going to use your asymptotes as a new guideline compared to your Cartesian plane. So this P is your x asymptote. So it's the one that's going to be going down like this, cutting the x-axis. This Q value is your y asymptote. It's going to be cutting horizontally like that. Let's take a look at an example. So here it says y is equal to 2 over x minus 4 plus 3. First things first, which coordinates is this graph going to go into? See here, it's going to go in, I'm just doing a sketch graph, right? Which means I'm not actually working out anything. I'm just showing you what it would look like. I am going to show you how we draw a normal graph though. So already judging from A, I know it's going to be in quadrants 1 and 3 because it's positive. Okay. Then I need to see my asymptotes now. I need to draw that. My x asymptote is minus 4. But what I need you to do is you need to flip the sign. This is only for this x asymptote value. So it's minus 4 here, but when I'm plotting on the graph, it needs to be positive 4. So because it's the x asymptote, I look at my x-axis, positive 4 should be around here. So then you draw your asymptote. Right. Then I have plus 3 here now. This is my Q, so it's going to be my y asymptote. So I look at my y-axis, 3 should be around here. Okay, now I got my two asymptotes drawn. Now notice how I said these asymptotes are now going to be the guideline for my graph. I'm not concentrating anymore on the normal x and y axis as my guide. So I know the graph's going to go somewhere here and it's going to go somewhere here. Okay, now I just roughly drew it. I'm going to show you that you need to actually work out values to get the graph. Okay. So how do we draw a parabola graph now? Hyperbola. Remember in your parabola, we had to find x and y intercept and we had to find turning point. For your hyperbola, you have to find your x-intercept, y-intercept, your x-asymptote, and your y-asymptote. Normally the equation gives us these two, so it's nothing to stress about. So let's take a look at this equation. It's y is equal to 3 all over x minus 1 plus 4. Already, I know that I have my x-asymptote and y-asymptote. This is my x-asymptote, but it'll be positive 1. This is my y-asymptote. So I got that down. My asymptote for the x is 1. My asymptote for y is 4. So that's sorted. Now I need to work out x-intercept, y-intercept. And remember, this is standard. Whenever you're working out x-intercept, you need to make your y 0. Whenever you're working out y-intercept, you need to make your x 0. So let's work out x-intercept. I wrote in my equation, I substitute 0 as y, and then I shift solved, and this is the answer that I got. Don't forget to put it in coordinate form because your y value will be 0, and whatever your x value you work out will be here. Then for your y-intercept, you have to make x 0. So I did that, and I got an answer of 1. Again, don't forget to write it in coordinate form. X will be 0, and then your y will be 1. Okay, now I have all my coordinates that I need. I can draw the graph. Here's your Cartesian plane. Also, make sure to double check your A so you know which coordinates it's going to go into. This will be 1 and 3 because it's positive. So I drew my Cartesian plane. What were my asymptotes? My x was 1, so I'll go on my x here. There's one asymptote. Then my y is 4. So this is y, let's say 4 is here. Okay, now what were your coordinates, your x and y intercept? So my x-intercept was 0, 0.25 and 0. So 0.25 should be around here. And then my y-intercept was 0 and 1. So on the y-intercept, 1 should be around there. Okay, now you plotted these two dots. Notice how I don't have anything in this, but I know that I need to draw like a boomerang here. So that one you'll just freehand because you know it's going in quadrants 1 and 3. But now also don't get confused. When you draw your asymptotes, I want you to treat that as its new quadrants. Like this is quadrant 1, this is quadrant 2, this whole thing is quadrant 3, and this whole thing is quadrant 4 now. Because I told you you're not looking at your old Cartesian plane. The only thing you'll be looking at your old Cartesian plane is for plotting your coordinates. That's all. For drawing the graph, you're going to look at your asymptotes as your new Cartesian plane. Okay, so I drew this one here because I know that it's going to be in 1 and 3, but there's no coordinates there, so I just freehand that one. But this is the one that I have the coordinates. So I'll join these two, go down, and then go out like that. Okay, so let's go over it one more time. I needed to find my x asymptote, y asymptote. I plotted those two lines down. That's my new guide now. I'm going to be looking at this as Q1, Q2, Q3, and Q4. Then I needed to find my x and y intercepts. I found those two, and I plotted them down here. So then I connected them, and I drew them with my asymptotes as the guideline. Remember, your graph can't touch the asymptotes. And now, because I saw my A was positive, I know that one's going here, so the other will have to go there. Okay, and this one you could just freehand. You don't really need coordinates for that. Another thing you should remember is, remember when we're working out x and y intercepts, sometimes you could get an error in your calculator. Let's say I was working out x-intercept, and I got an error. All that means is that there's no x-intercept at all. Even if you're working out y and you got an error, there's no y-intercept, so you don't need to plot it. So now we learned how to draw the graph. What if they gave us the graph and they said determine the equation? All you have to do is write out your general equation first. Y is equal to a over x minus p plus q. Now we need to fill in a, p, and q as numbers. So a will work out last. P and q, we know what those are. We know that p is my x asymptote. We know that q is my y asymptote. So p, where's my x asymptote? You look, the x asymptote is the vertical one, and the y asymptote is the horizontal one. So here's the x asymptote as my vertical. So x is 1. But remember, when you're putting it into the p's place, you need to switch the sign. So it's 1 here on the graph, but when you put in the equation, it should be plus 1. No, wait, it's 1 on the graph, but when you put it in the equation, it should be minus 1. So that's why I got minus 1 here, because I switched the sign from there. Now my q is the horizontal asymptote, so it's 2. That one I leave as is, plus 2. Okay, now all I have to solve for is a. What you can do is x and y, any random coordinate on your graph. Here I got a random coordinate of 3 and 4. I can take it, put it in x place and y's place, and then a will be my only unknown, so I can shift solve and get a. So that's what I did. I put 4 here, I put 3 in x's place, shift solve, remember, sub any random coordinate, and I got an answer of 4. So that's what a was equal to. Then I rewrite my equation. Y is equal to 4 over x minus 1 plus 2. And that's your final equation. Then we come to range and domain of a hyperbola. It's pretty simple. All you do is for your range, you put y as the element of real, and then you put y is not equal to your asymptote value. So what's your y asymptote? Remember, it's the horizontal one. So see, it was 2, so you say y is not equal to 2. Then for domain, same thing. X is the element of real, but x is not equal to, what's your x asymptote? It's the vertical one, so it was 1. So it's not equal to 1. And that's your final answer. Then we come to axis of symmetry. Again, symmetry, it's how many times you cut the graph so that they equal halves. In this graph, in hyperbolas, you can cut them 2 times like that. So let's call this line, okay, I'll just put it as the positive line, and this line is the negative line. I'll show you why now. Because remember in parabola, they said determine the equation of your axis of symmetry. But that one was easy because it was line going straight down. Here it's two separate lines now, and it's diagonal lines. So this is what you're going to do. There's always going to be a line going upwards like that, and then there's always going to be a line going downwards like that. This line we take as being the positive line. So I'll put it as positive line. And then this line is our negative one. Now, they could ask you for the equation of this axis of symmetry line or this axis of symmetry line. But this is what you need to do. Because they're straight lines, they're going to have a standard equation. Y is equal to mx plus c. Okay, now, this is our positive line. See, it's going upwards like that. If they ask you for the equation, this is how you'll do it. Your gradient and your c we need to find. But one thing about this is your gradients will always be the number 1. In this positive line, we'll have a gradient of positive 1. Okay? And in this line here, we'll have a gradient of negative 1. Right. Now all that's left is for me to solve for the c's in both the equations. So what you can do is, notice both these lines will touch at your asymptotes, like the asymptotes cut them. So all you do to solve for c is you put your asymptote values in this x and y. So let's say my y asymptote was 2 and my x asymptote was 1. So in your y's place, you're going to substitute 2. And in your x place, you're going to substitute 1. Like that. Then you will solve for c basically. So that's 1 times 1 is 1, take it on the other side. C basically becomes 1. Okay, so then if you rewrote this equation, okay, I'm going to take this off and write it on there. If you rewrote the equation, it should read as y is equal to 1x plus 1. Okay, that's for this positive line. How are we going to get the negative one now? Same thing. To get your c value, you need to substitute your x and y asymptotes. So what was our y asymptote? It was 2. What is my x asymptote? It was 1. So my y asymptote was 2. Minus 1 was the gradient. My x asymptote was 1 plus c. So then eventually when you work out c, it should be 3. So if I had to rewrite the equation now, it's going to be y is equal to minus 1x plus 3. Okay, so let's recap that one more time. If they want axis of symmetry equations for a hyperbola, all you have to do is draw one line going there, one line going there. It cuts the graph equally. This is your positive line. This is your negative line. If they want the positive line equation, you're going to put y is equal to mx plus c. Your m will be a positive 1. That's always, right? It'll be a positive 1. Now all you have to do is solve for your c. So what you do is you put in your x asymptote value here, your y asymptote value here, and your c will be the only unknown. So you can shift solve and then get c and then rewrite the equation. Then if they ask you to work out this asymptote here, the decreasing negative one, you'll write y is equal to mx plus c. You'll substitute your m as negative 1. That's standard. Then same thing. To work out c, put your x asymptote value here, y asymptote value, shift solve, get your c, and rewrite the equation. Okay, last thing when it comes to hyperbolas is, if they were to ask you the question, is this graph increasing or decreasing? This is how you should go about doing it. So see, always move from left to right. I'll tell you that just now, right? Why? So look at this graph. Picture is like a car. Right, so it's going in this direction, which is down. And then same here, the car is going down. So this graph, when it looks like this, you'll say it's a decreasing graph. That's just an easier way for you to remember it. Then if you look at this graph, remember, the reason why I said moving from left to right, that's how you remember it. Then here, if I'm moving from left to right and left to right, notice your car is going up. And here, if you're going from left to right, your car is going up. So then this is a increasing graph. Just remember that.